Hey, welcome back. This is episode 19 of the Salesforce Data Cloud Masterclass. Today, Salesforce Data Cloud Zero-Copy Databricks integration. Delta sharing, Apache Iceberg uniform and Bi-Directional Lakehouse federation. Let's get into it. Here's what we're covering today. Architectural overview of Zero-Copy Databricks integration, then, Delta sharing protocol and Open Lakehouse standards, then, metadata translation, Delta Lake to Apache Iceberg uniform, then, provisioning data cloud federated data lake objects, DLOs, then, mapping zero-copy DLOs to data model objects, DMOs, then, bidirectional federation, exposing data cloud to Databricks, then, query pushdown mechanics and performance optimization, then, enterprise security, Unity catalog and data space governance. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. Welcome back to the Salesforce Data Cloud Masterclass. In episode 19, we are tackling the frontier of enterprise architecture, zero-copy integration with Databricks using Delta sharing and Apache Iceberg.
Does this mean we can query petabytes of Databricks ML predictions inside Data Cloud without running expensive ELT jobs or duplicating data?
Imagine you are running an enterprise platform with petabytes of telemetry and sales data sitting inside Databricks Delta Lake tables. Traditionally, getting this data into Salesforce meant building costly ETL pipelines that constantly duplicated records, inflated storage costs, and introduced sync latency. With Salesforce Data Cloud Zero-Copy integration powered by Databricks Delta sharing and Apache Iceberg, you read data natively in place without moving a single byte. Let's explore how live data federation transforms your enterprise architecture. Think of Delta sharing as a secure, open protocol that streams metadata and data file references directly from Databricks to Data Cloud without proprietary lock-in. Instead of physically copying Parquet files over the network, Data Cloud queries the Open Delta Lakehouse protocol using secure bearer tokens and pre-signed URLs. This means when a data scientist updates customer propensity scores in Databricks, those updates appear instantly inside Data Cloud. Let's see how this real-time link removes stale ELT batch jobs forever. You might wonder how Data Cloud seamlessly reads Databricks Delta Lake format when enterprise architectures often standardize on Apache Iceberg. Salesforce accomplishes this by leveraging universal format, or uniform metadata translation, converting Delta Lake commit logs into Iceberg metadata specs on the fly. This architecture allows Data Cloud's underlying query engine, Hyper, to execute sub-second federated queries directly against your object stores. Imagine executing real-time segmentation on multi-terabyte tables without any data ingestion delay. Setting up a zero-copy Databricks connection requires connecting your Databricks recipient profile to Data Cloud's federated data source settings. Once the Delta sharing activation link is authorized, Data Cloud automatically discovers the shared tables, schemas, and data types without manual mapping. You can immediately register these remote tables as data lake objects, bridging enterprise lakehouses directly into your customer data platform. Let me show you how security and schema evolution are handled automatically during synchronization. Now that your Databricks Delta tables are mapped as zero-copy data lake objects, the next crucial step is unifying them with the cloud information model. You map these federated DLO fields to standard data model objects like individual, sales order, or account. Because this data remains in Databricks, Data Cloud executes virtualized queries only when identity resolution or data graphs request the data. Imagine powering real-time Agentforce AI agents with live predictive scores straight from your data science lakehouse. Zero-copy isn't just a one-way street. Data Cloud also exposes its unified profiles and calculated insights back to Databricks using Apache Iceberg shortcuts. Imagine your data science team opening a Databricks notebook and querying fully deduplicated Salesforce unified profiles directly alongside raw clickstream data. Because both systems share access to underlying object storage via Iceberg metadata, neither side incurs duplicate storage fees or governance headaches. Let's analyze how this unified Lakehouse paradigm enforces zero data duplication. A common architectural pitfall with federated queries is network egress cost and slow query latency across cloud boundaries. To solve this, Salesforce Data Cloud uses intelligent query pushdown, sending filter predicates, projections, and aggregations directly to the Databricks SQL warehouse engine. Instead of pulling millions of raw rows back to Data Cloud, only the precise, filtered result set is returned over the wire. Let's walk through an architectural execution plan to see how predicate pushdown maximizes performance. When bridging enterprise platforms, security architects always ask how data access controls and compliance policies are preserved across boundaries. Salesforce Data Cloud enforces data spaces and security predicates, while Databricks Unity Catalog governs table and column-level permissions at the source. Token exchange mechanisms ensure that queries running from Salesforce strictly respect Unity Catalog audit logs and governance policies. Now you have a complete, secure, enterprise-grade zero-copy architecture connecting Databricks to Salesforce Data Cloud. Alright, let's wrap up. Here are the key things to remember. Zero-copy Databricks integration uses Delta sharing and Apache Iceberg uniform to eliminate data duplication and expensive ELT pipelines. Federated data lake objects allow live data science model predictions to be mapped into standard data model objects instantly. Bi-directional sharing empowers Databricks data scientists to query Data Cloud unified profiles directly without outbound storage fees. Query pushdown mechanics and Unity Catalog integration ensure high performance, low egress costs, and bulletproof security governance. If this helped, hit like, it really helps the channel. Next up, Episode 20, Advanced Data Transforms, Real-Time Streaming SQL versus Batch Vector Transformations. See you tomorrow.